much here is call on Ken and Ruth Wright, who have made immeasurable contributions to the study of paleohydrology as well as current policy and engineering matters. So Ken and Ruth, if you'd come on up.
Okay.
And then, of course, we're going to break, and we're going to have Ken Salazar for our lunch speaker. And there is a presentation from the Water Law Review staff to the two of you that will happen after your presentation. But first of all, I want to say how much I owe to these two for enriching my career and my ability to write in the Water Law Review. I've written several articles about their work in Peru and Mesa Verde and in the Docket magazine of the Bar Association about the work in Hovenweep. These people give, and give some more. Ken Wright has been a successful engineer in Colorado for over 50 years. Did two important studies that led up to the 1969 Adjudication Act that set up the 7 water divisions. Ruth Wright, a former legislator, Colorado legislature, Water Quality Commission, Great Outdoor Colorado Board, a client of mine when I was counsel to the Northern Water Conservancy District for 17 years. But being out in the field with these people, looking at what the ancient people did in the way of water conservation just opened my eyes totally. And so I can't say more to you than the water community breeds lifelong friendships, and you're certainly among those people we need to honor for what you've done, not only for Colorado and the United States, but importantly Peru, and the work you've done in Europe on paleohydrology. So I think you have a presentation, and then the law review staff wants to make a presentation to you.
Okay.
Okay.
I'm just going to sit over there because this is his presentation.
Okay, great.
Yeah, what we're going to do is take you back to granddaddy droughts going back 1,500 years, and what we're going to do is show you how it affected established empires because it was difficult to recover from the impact of these droughts. So we're going to start out with an empire, the Tiwanaku Empire, south of Lake Titicaca. And that empire started in the maybe 400 AD and was a thriving empire south of Lake Titicaca with a very strong agricultural base. We know what happened climate-wise down there because we have good records from Lonnie Thompson from Ohio State. And what he's done was to core this Calcaya ice cap going back to 480 AD. The average thickness of the ice layers was 1.38 meters, and based on these studies of the cores, he's able to determine temperature and from the oxygen isotope, and he's able to find out when the worst dust settled in the ice from blowing dust and drought. At any rate, we have a good record of precipitation, and we know there was a granddaddy drought that started in the 6th century. The red line on the left is the first one I want to talk about. And that was a disastrous drought for them, but it was only lasted a relatively short time. So this empire that has been established since 400 AD went on very well into the let me show you how they what they did to recover from the seriousness of the drought. They redeveloped their agricultural system by constructing 48,000 acres of what they call the mound system. This was, they took water from, drained it out of Lake Titicaca around the edges, built a mound in the middle, and the water not only provided irrigation, but also warmed the plants and the soil so that they could extend their growing season. Keep in mind they're at we're looking at 12,000 feet of elevation. The long-term record from the Quelccaya ice cap shows certainly the first drought I talked about, but then we get into the 950 AD, and they had, by this time, had an active mound system, but when they got into this long-term drought that lasted 350 years, the empire collapsed for the simple reason that the central authority could not provide food for the population, and the empire collapsed, went away, and the Aymara Indians around Lake Titicaca and in Bolivia never really recovered from this drought. I just want to show you a little bit further how the Little Ice Age started, and during the time of Machu Picchu, it wasn't a matter of abandoning Machu Picchu because they ran out of water, because we can tell by the ice cap that it was actually a period of increasing moisture for Machu Picchu and the Inca. The sad story is that shows over to the right side with the following hydrograph, and the Spaniards had a tough time ruling Peru and the rest of the South American countries with this devastating decrease in precipitation all the way over into the 17 and 1800s. Tiwanaku was it's a wonderful place to visit if you go to Bolivia. It was grand and well established, and it was kind of a forerunner of the Inca. But this gives you an idea of the kind of grandiose capital they had, and with this drought, it all went down the tubes. North of Lake Titicaca, there was another empire called the Wari Empire. And the Wari Empire survived the 1563-94 drought and substantial flooding after that. But after 950, the same drought that affected Tiwanaku crushed the Wari Empire. We're familiar with one of the outposts of the Wari Empire. This is called Piquiacta, not far from Cusco. And it was an administrative center for the Wari Empire. During the drought, things were so bad that they abandoned this administrative center, and when they left, they expected to come back. Instead of walking away, they carefully stoned off all the walls, all the doorways in the walls, so that they could preserve it for when they did return. They were good at water management, these Wari people. This is an aqueduct that fed water to Piquiacta. At the same time, early on, during the 6th century, the Mochi kingdom, wasn't big enough to be an empire, but it was a kingdom centered around northern Peru. And one of the periods of disaster for them was a period of significant El Nino flooding that came out of the mountains, washed away their capital city. For instance, here you see the remains today of the pyramids that they had at their capital city, the temple of the moon and temple of the sun. But this flooding washed away not only their buildings, but also the agricultural soil. So it was a matter of totally abandoning the capital and moving elsewhere along in northern Peru. The Inca learned from these past disasters, and they tended to keep out of the floodplain, and they were able to adopt the previous empire's terracing. The terracing was not in the floodplain, and yet they were able to run their irrigation water over to the floodplains. Now this happens to be Machu Picchu. They didn't have any irrigation. They did not need any irrigation because they ended up having about 80 inches of rainfall a year. This gives you an idea of that same record, climate record from the Calcutta ice cap, expressed a little differently to show how fortunate the Inca were in terms of not long after they were moving ahead with their empire, there was a period of increasing precipitation. The yellow is good. The dark side is below average. I talked about the Inca and their terraces. This is the kind of terraces they built throughout the Sacred Valley and elsewhere in Peru. This happens to be Pisac, and they were able to grow food surpluses for their people. They had a population of about 10 million, and they had a third of the population wrapped up in military and in building public works, because they knew the secret to agriculture and were able to produce these surpluses year after year. I want to take you now to southwestern Colorado, and you see much Mesa Verde in here, and we have done a little bit of work at Mesa Verde, and I want to tell you a little bit about that. But they too had droughts. And we've got good records of those droughts. For instance, this is tree ring data from Jeffrey King, University of Arizona. And it goes from 480 all the way up to nearly current time. I think the last line I have there is about 1980. The red is bad, the blue is good. The horizontal line is the 1,500-year average at, can't quite see what the number is, but it looks like it's about 18.2 inches, 1,500-year average. And the last 50 years down in the area of Mesa Verde has been roughly that amount. I want to call your attention to the granddaddy drought, 1135 to 1180. 1135, when the Geological Survey drilled test holes at hill roads along the South Platte River in northeastern Colorado, they came across the evidence of that same drought in 1135 existing along the South Platte River. That's when the sand dunes started rolling from northwest to southeast across the northeastern part of Colorado. And it ties in with that terrible drought. So it's a widespread drought that went all the way into central U.S. This is also about the time that Chaco Canyon stopped growing. They stopped cutting logs for doorways, and people began moving northerly up to other settlements along the San Juan. The other drought that you're probably more familiar with is 1275 to about 1300. This is the one that created such havoc for our Indian friends from the southwestern Colorado. And what happened was that there was lots of stress and uncertainty, warfare among the various pueblos, and eventual moving away down into the south, down into old New Mexico, down into New Mexico, and elsewhere. But they gave up the southwestern part of the state. One of our studies in southwestern Colorado was Moorfield Reservoir. we started that one in 1994, and it was a mound. And the real question was, how could a reservoir be above the ground? Well, it was because over 350 years of operation of this reservoir, so much sediment came in, it rose up and grew out of the ground until it was about more than 20 feet above the valley bottom. We had a good opportunity to cut a trench across this reservoir, and we had lots of archaeologists, experts in southwestern archaeology. John Roll, the state geologist, was our safety manager, because being in a trench, being on the federal property, we certainly had to follow OSHA rules. The trench told us lots, but what I found most interesting were the periods of sand, which represented flooding in the Moorfield Canyon, and then the clay, which was for long periods of low flow. It was fine clay. It's kind of clay that sanitary engineers would use for sealing solid waste sites. It's that tight. Probably 10 to the minus, for those of like our state engineer here, probably 10 to the minus 8 in terms of permeability. 10 to the minus 8 centimeters per second. One of our favorite spots is Farview Reservoir, that many of you know as Mummy Lake. This reservoir was dated by Bredernitz, our colleague, who was our scientific leader on this project, had been studying it for a long, long time. David Bredernitz was he's passed away now, but he was the dean of Southwestern archaeologists. But we have here a reservoir that is dated from about 950 AD to 1180 by David Bredernitz, using all the techniques that archaeologists use. The sediment was also brought in and deposited in the reservoir, and they had to clean it out. And what they did was to dig it out and pile it on the side. To keep it from washing in, they built a retaining wall to keep the wet sediment from rolling back into the reservoir. We have here a very super duper stairway, which is an enigma. Why would they need a fancy stairway, really a fancy one, to go in for utilitarian purposes in a water supply reservoir? And in effect, what it amounts to is that at the end, there were other uses for the reservoir, some type of social type use of that facility. But nevertheless, Farview turned out to be a real enigma, because ever since about 1890, when the first explorers were looking at these sites, nearly everybody had a different opinion of what, well, let's go back and look at it, what this Mummy Lake was. And it used to be thought as being a giant giant what?
Dance platform.
Dance pavilion.
Yeah. Well, yeah, actually, the Park Service had it labeled as such a difficult site to say. We don't quite know what it is, so make your own choice. It could be a dance pavilion, or it could have been a reservoir. And until the time that we did our work, that was the scope. At any rate, let's go on. Another reservoir, and this is the first one that Greg Hobbs worked on with us, we named it Boxelder Reservoir. And it was an early reservoir from 750 AD to 900. And here we have Ruth with an auger that was loaned to us by the Bureau of Reclamation, so that we could go all the way down to the very bottom of the beginning of the reservoir. I want to take you over to another site, which is Mug House. And this is mostly all 13th century. They had to walk about a mile or a mile and a half to get water from a spring, except that they were ingenious enough to create a 4,000 gallon cistern. And here we have Greg and myself standing in the cistern, and it still works. Where'd they get their water? Well, when the rainfall happened, just a little bit on the bare rock up above, it was rooted then to a chute, and it dropped right into the cistern. So we figured that roughly maybe 20 times a year they would get some water, and about every 1.5 years on the average they would be able to fill the 4,000 gallons. We then went to Hovenweek, which is a marvelous monument with 5 units in western Colorado and eastern Utah. And here we see Greg and one of his, I think his grandson, rediscovering a spring. And we knew the spring existed because the government had filed water right on it many years ago. And using that information, we were able to determine about where it should be located. And this is the kind of exploration work that Justice Hobbs would do in his spare time. We also had a reservoir that the Indians used during the droughts. And this was a small reservoir that was about a half mile from the main pueblo of Hovenweek. Here we see bare rock in the background. It was that kind of bare rock that was so productive in terms of causing runoff to fill the lake. During one of our trips, we decided that we wanted to explore the Mountain Ute Tribal Park, which is a marvelous place. And here are the 2 of us with our Indian friend shown here, after examining something called two-story house, which was famous because it was a picture taken by William Henry Jackson back in 1874, and it was you can chalk it up as being the first cliff house photographed and published.
Ken, we're probably going to have to wrap it up here because
Yeah,
the students want to make a presentation today.
Let's do that. So we're wrapping it up, and analyzing ancient rainfall and hydrology is something that is a joy for us, and it provides lots of opportunities for publications and to learn about what the ancient people did. So thank you very much.
So the students have a presentation for you. Yeah.
So in addition to their many decades of intellectual contributions to the water community, Mr. and Mrs. Wright this year made a significant contribution to the Water Law Review in the name of Justice Hobbs. In addition to allowing us to support events like this, it'll allow us to do things like send students to conferences that we previously couldn't do, didn't have a budget to do that, among many other things that it'll allow us to do to promote water law and policy scholarship. And to express our gratitude for that, we wanted to give you this show of our appreciation, which includes some photos of them with Justice Hobbs and his wife, as well as the Volume 20 masthead and then the open space there. We took a picture today that will be fit into there, but we wanted to thank them for their intellectual and their contribution to the Water Law Review and their decades of service to Colorado. So.